One of the big ideas in geometry is the idea of triangles being similar. And first of all, you need to understand what is similarity in terms of triangles. And as it says up here, the polygons are similar only if corresponding angles are equal and also the corresponding sides are proportional. So the corresponding sides aren't equal, but they have a similar proportional relationship. For instance, maybe if you take all the sides in the smaller one, if you were to double them, they would equal the sides in the larger one. So that's what we mean by proportional here. And so we're going to be talking about triangles here, triangle similarity, although we can also look at polygons are similar as well. But let's talk about triangle similarity here. There are three different ways that this could happen. One of them is what we call SSS, and similarity is this little squiggly line right here. And so if we have we can have similarity by what we call SSS, and that means three corresponding sides share a common ratio. So for instance, if you're comparing the smallest side to the other smallest side, we could say 6 over 3. Now what is 6 divided by 3? Well, that's 2. Also, if we compare the next biggest sides, so we would be comparing 8 versus 4, 8 divided by 4 is 2, and likewise if we look at the biggest sides, 14 divided by 7, every single time here the ratio is 2. So all the sides in the bigger triangle are twice as big as the ones in the smaller. So that would be the first kind of triangle similarity, is what we call SSS similarity. Next up, we have a second type of similarity, and I'll go ahead and reveal that right now. And this one is where we have angle-angle similarity. We call it double A similarity right here. And that's when we have two pairs of corresponding angles are equal here. And so as you can see here in the diagram, we have angle P is congruent to angle Z. So the measurement of angle P equals the measurement of angle Z. Also, if we look at the picture here, it says that angle Q has the same measurement as angle Y. So the measurement of angle Q equals the measurement of angle Y. And so once we have that, we have what we call similar triangles. There's no need to have a third because the third side has to be whatever's left over from 180 degrees. And it will be the same for both. So once we have two, we're guaranteed a third. So that's why we only really need two, is because of the triangle angle sum theorem that says that the sum of the triangles, the sum of the angles in a triangle add up to be 180 degrees. The third way we can have similarity, and there are only three ways with triangles, is what we call SAS. And as it says here in the definition, two pairs of corresponding sides share the same ratio, and the angle that's between them are equal. And that's why we write this SAS, because you'll notice here A is between the two S's. So that means the angle is between our two sides. And so what we do is we look at the angles first, and you'll notice here these angles are both 57, and then we know the sides that are making up that angle. So we have 8 and 14 make up the 57-degree angle, and likewise 12 and 21. And what we can do is look at the ratios here. So if we look at 12 and 8, if we were to take 12 and divide by 8, we would get 1.5. So that's that ratio. If we look at the other ones here, we have 21 and we have 14. And if we were to take 21 divided by 14, we would also get 1.5. So that means these corresponding sides share the same ratio of 1.5. That's the first part here. And also the angle between those two sides are equal. So this is what we call side angle side. And once again, that angle must be between the two sides. If the angle was a different angle here, then it would not work. So those are the three ways that you can have triangle similarity.